All right, so the way this works is we're gonna get an 8 by 8 grid of numbers, and then you have to zigzag to get the line of numbers, the array of numbers. So you start from here, you go left, down, up, right. That's basically the loop. Left, down, up, right. Left, down, up, right, right? And you do that to get all the numbers. When you get to the last non-zero number, you can basically cut it short and put in EOB, which are here after 1. So it was like, just imagine everything else are zeros over here. So that's EOB right there. Okay. Now, so if I'm correct, to actually encode these decimals that you have there to this, so down here is the answer. So this shouldn't be here. But it's already there because we did the example. So I'm just going to explain how we got it. So the 20, for the 20, you need to, well, first of all, 20 is the number, right? But when you're on your first one, you have to subtract it from the last element of the last one or some shit, bro. You have to subtract it from something. So that's why you have 20 minus 4 over here, because this is your 20, and you have to subtract it from 4. Oh, the DC of the previous block, I guess? Yeah, you subtract it, so it's 20 minus 4, which is 16. So 16 to 31 is in here, right? This is category 5, right? If I'm not blind. Yeah, 5. Yeah, that's 5. And looking at DC for the first element of the list. So we know category 5. So then we go to the next table here, and category 5 corresponds with base code 110. And this is for DC, which is the first element of the list, 110. Length is 8. So we already know we have to have 110 in there. And our total length is 8, which means we have 5 more spaces apart from 110 to represent 16, right? So, yeah, so actually you just have to write 16 in BCD for the other 5. For the remaining bits, you just write it in BCD, which is in binary. So 16 in binary is actually this. So yeah, 1, 2, 4, 8. 1, 2, 4, 8, 16, right? 16. And that's your code right here. Then you move on to -3, and it gets a little funky. So for -3, you're gonna come back to your range table. However, this time we're looking at AC, at the AC column. We only look at the DC for the very first element. So now we go in for -3, which is here, right? This is the range. And it is 0, 1, 2, 0, 1, 2. So if I can see, it's category 2, right? Category 2. So then we go to category 2, and we check the base code for category 2. The base code for 2, oh shit, no, actually, this is for DC, sorry. DC is the first element, so we don't use this one. We use this one, so this is for AC. And we come to category. So here we have run/category. The run, okay, 2 is what we want, right? So there's a 2 here for category. There's also a 2 here for run 1. There's a 2 for run 2. The run is the amount of zeros between the element that you're doing and the last non-zero element. Or basically the amount of zeros before your element, basically, consecutively. The number of consecutive zeros before your number. This is -3, this was 20, so we have no zeros between. So we're gonna use run 0. Run 0 and category 2. So that's run 0, category 2. Base code is 0, 1. The number we actually want to represent is -3. So we know our length. Our length is what? We don't know our length. Our length is what? 4? 1, 2, 3, yeah, 4. Length is 4. Base code is 0, 1, which is 2 bits. So we have 2 bits left to represent -3. What is -3 in BCD? You use 1's complement. You take it off 3. So 3 is 1, 1. And 1's complement is just input. So that becomes 0, 0. So that's how you get 0, 0 right here. Yeah, and you do the same for -5. You'll see that we got 0, 0, 1 for -5. Oh, no. Okay, that makes sense. Yeah. It's supposed to be kind of long. Yeah, so you do the same thing for the others. Let me see, should I do -5? Okay, I'll do -5 just because. So -5 is, you come, -5, you come here, this range. This range is category, can I see, bro? 1, 2, 3, 4. 1, 2, 3, 4. Category 3. Category 3. Category 3 corresponds with. Category 3 corresponds. Oh, how many zeros before it? 0. So it is 0, 3. 0, 3 is here. So that's 1, 0, 0. Length 6. So we have 3 more bits to represent. 3 more bits to play with to represent minus 5. Yeah, minus 5 is 1, 1, 2, 4. 1 on 4 is 5, so that's 1, 0, 1. Flip it, 0, 1, 0, right? So that's why you have 0, 1, 0, and our base code was 0, 3, 1, 0, 0. So that's why you have 1, 0, 0, 0, 1, 0. Boom. Lovely stuff. Jump to minus 4 because we now have a run of 3, just to show you how it looks. So you come to minus 4. I think it's the same place. Yeah, same place. Category free again, which means what? 1, 0, 0. Category 3. However, we have 3 zeros. 3 zeros here. So that's gonna be run of 3 and category 3. So that's 3, 3. Here. 3, 3. This long ass number, bro. Since we did it in class, I remember 7 ones and 3 ones here. 1, 0. So we have 11 digits here. So we wrote those. So we have 3 digits left to play with because our length is 14. So we have 3 bits to represent what, minus 4 is it? Yeah, minus 4. And 4 is 1, 0, 0. Flip it, 0, 1, 1. And you end up with 0, 1, 1 there. Yeah, so these are going to be all the decimal encodings. And when you get to your EOB end value, you just replace it with 1, 0, 1, 0. That's it there. Yes, sir. Yes, sir. There's a 1 here. It's supposed to correspond with this one, but we didn't really go through it. So just like you just put 1 there. How is log base 2 of 10 equal to log 10 of 10 over log 10 of 2? How? And he gave these. Are these just constants? Okay, so the way you do this is you just count the elements. So first one is 1, 2, 3. Here you have 1, 0, 2 ones, 3 zeros. So that's 1, 2, 3. After that you have 2 zeros, 3 ones, 1, 0. So that's 2, 3, 1. And then you start with 1, then you throw in a 0 at the beginning, and you continue.